post-content discussion of the LeetCode contest. Today we will be discussing the solution for the problem A and B. Let's start with the problem A. The problem A is flip square submatrix vertically. You are given an m cross n integer matrix grid and three integers x, y, and k. The integers x and y represent the row and column indices of the top left corner of a square submatrix, and the integer k represents the size of the side length of the square submatrix. Your task is to flip the submatrix by reversing the order of its rows vertically. Return the updated matrix. You can simply see here you are actually want to swap the rows of the submatrix, right? So this row is swapped with this last row, and it will be remain same. And you can also see that this row is swapped with this row. So it is the idea that you are asked to only swap the rows of the submatrix. Let's discuss the solution in detail. Let's see. You are also given a starting point where you can actually start the matrix, and from that you need to have like k cross k matrix, and that the matrix should be the rows in the matrix should be swapped, right? So let's discuss the solution. what it, so the basic idea is to, if you know how to swap the rows in the matrix, you can actually solve the problem very simply here. So that is all about the problem you are asking about. And let's see. So the idea is that you need to swap this row with this row, right? Like zeroth row can be swapped with the second row, and you cannot swap the single row here. So that's remain same. And let's see what you can do here. So in this matrix, you can simply see here. So the zeroth row. So the zeroth row should be swapped with. So zeroth row should be swapped with the third row, and the first row should be swapped with the uh, second row, right? You can see. So the zeroth row should be swapped with the third row, and first row should be swapped with the second row, right? So this is all about the problem this is asking about. Let's how should we swap these elements? Let's see. Do you think that should we need to traverse all the rows? No, right? If you traverse like n is equal to here 4, right? 4 n by 2, you need to only traverse up to the half of the part of the matrix, like 2. So while I is less than 2, you need to traverse until this point, and you can simply derive some formula that you can actually swap this last element. How should you solve this? Like, let's see here. So the first I is equal to 1, right? You need to swap. No, wait, sorry. I is equal to 0 should be swapped with the I is equal to 2, right? So here n is equal to 3, right? So we don't want to change anything in the column, so column remains the same. So we only changing the rows here, right? So what I can do is, I want 1 here at the place of 7. 7 should be go at the place of 1, right? So when n is equal to 3, I want to swap with 2. I want to get 2, right? What I can do, n minus I minus 1, right? If I do this one, when I'm standing at the I is equal to 0, I simply get the last element which I want to swap, like n minus I minus 1. So for the I is equal to 0, I want to swap with this value, so that I can actually swap the last row with the first row, and corresponding, like it will go on swapping like this. Let's see how it will be working. Like when I is equal to 0, let's say n minus I minus 1, right? So when I is equal to 0, what this is value, n is equal to 3, n is equal to 3, I is equal to 0, 1. You are getting 2, right? What I can do is, I can simply write swap matrix of, I will erase this one, matrix of, I want to swap with I, and the column should not be changed here, right? And again matrix of, here you will get, you need to swap this seventh and last row, right? Last n minus last row. How will you get the last row corresponding to that element? N minus I minus 1, and the column should be same, right? So this is how you can actually swap the rows in the matrix, like corresponding rows. This is how you can swap the first zeroth row with the second row again. Let's see. It will be work with all the rows you can swap. So here, what I am taking is I am keeping two pointers here. I will be keeping. Wait 1 minute. I will be explaining here. I will be keeping one pointer here. This is a top pointer, and this is a end pointer or bottom pointer. Let's say take it as bottom, right? Take it as bottom pointer until the both pointers will cross each other. Then until I will be go on swapping the rows, right? Let's say while I can simply write while. I will be writing code here. What I can say is, what I can write here is while the top is less than bottom, right? They should not cross each other until I will be swapping these rows. How should I swap these rows? I want to swap this element with this element and this element. I will simply traversing all the columns. From I is equal to 0, I is less than some m is the number of columns, and I plus, right? Inside this, I am simply what I am doing is I want to keep this one below. What I am doing is inside this for loop every time I am swapping on, let's say, swapping grid of what top, right? Top is the top row, the first row. Top and column should be same, right? This should be I. And again I am swapping with the next element should be with the last element, right? That is grid of, it should be the bottom row and the column should be same, right? I'm simply swapping the rows here. I think it will be something confusing here. I will try to. So you all got the how we are proceeding here. So I don't want to write the code here because it will be taking time here. So while you will be not crossing the top and bottom until you will be go on swapping the last element and first element. The logic to swap element is matrix of. I already wrote that this technique here. So this is the line which is actually swapping all the rows, and we will only running until we will be not crossing each other, right? So this is a simple idea, and you can see here you can keep bottom. Let's say we will be writing like top is equal to something like we are given some starting point here. So that means the top should be x here. That is a starting point, and let's say bottom should be, what is the bottom? That is the k plus x, right? Minus 1. That is we are following zero indexing here. And for row we want to actually get like for column the starting point should be column left is equal to column left should be like you are given starting point y, and the column right should be, that is the from here to here we are actually traversing the submatrix, right? So this is the, what is this is the top, and you can see this is the bottom, and you are actually traversing from this element to this element, right? So what I can say, this is the column left, and this one would be the column right, like, okay. For every row, in every row we are actually traversing from the column left to the column right. So that is how we are actually traversing. So the column right would be like k plus y minus 1, right? So this is how we can shifting the starting point position, right? From here we are actually shifting to here by adding the x here, right? At the last we are actually getting the k cross k matrix, which is a square matrix, and we need to swap the rows in that matrix. So we all got the all the values here. What you can do is you can simply while while top is less than bottom, right? Until we will not cross the top and bottom, we will be go on swapping the corresponding rows here. Inside this, I am writing for loop I is equal to 0, not 0 here. We need to write something like column left, that is the left side which we are starting the column here, and I is less than column right and I plus plus, right? So this condition, so we are already following 0 indexing, we don't need to skip that last row, last column here. Column right means that would be the last column, until we will be simply swapping grid of what, this is the top row, and the column should be remain same for the both the values. The grid of, this is the bottom row, okay, and the column should be same, right? So this is the pseudocode which you can, and every time we are increasing the top and we are decreasing the bottom. This is the pseudocode which you can actually have in the code editor same. So every time from here, this is the top and this is the bottom, right? Every time I'm increasing the top and every time I'm decreasing the bottom. At some point they cross each other. At that time I am simply what I can stop the while loop. Inside this, every traversal of the row, I'm simply swapping all the elements like in the column. So this is all about the. Let's see the code in the code editor. So this is the same code which I have wrote in the whiteboard. Let's see. Starting point is we already given, and the left point, that is the column, right? That is the starting column which you are actually given in the question, and the end point should be the end. This means this is the what, last row, right? Last row, and this is the last column. And after that, for each row you are when you are traversing each row, you are actually um, swapping the first row and the last row and corresponding row to each other. Simply you are starting, you are increasing the first pointer, top pointer, and you are decreasing the bottom pointer. This is all about the first question. Now let's see the question number 2. Maximum k to sort a permutation. You are given an integer array nums of length n, where nums is the permutation of the number in the range 0 to n minus 1. You may swap the elements at the indices I and j only if nums of I and nums of j equal to k, where and denotes the bitwise and operation and k is a non-negative integer. Return the maximum value of k such that the array can be sorted in non-decreasing order using any number of such swaps. If nums is already sorted, return the 0. Permutation, you already know the what is the permutation here. Let's see the question in detail. So the question is asking that you are given some permutation, array of permutation, like let's say this is the 0 3 2 1 is the array of elements. So you are asked to swap the elements and you want to sort the array. You need to sort the array and you can swap the elements any number of times. Let's say if I sort this element, okay, then I will get the sorted array right here, 0 1 2 3. So when you will be sort this element, so you will only sort this element when you are actually choosing some k. So 3 and 1, you are getting some value k, right? You are swapping both the elements and you are getting the area sorted. And when you are swapping these two elements, you need to follow one condition. When you are doing the AND of these two elements which you want to swap, that should be equal to k. You need to choose such large k which is possible for the all the swaps. Let's say if when you are doing 3 and 1, 3 is 1 1 and 0 1, you will be getting 1, right? Here in this test case, you can see that if you take the k is equal to 1, you are actually able to solve the sort the array here, right? So like this, we will be solve the problem here. This is the problem statement you are actually asking. In the AND operation, you need to remember this condition that when you are doing AND of a comma b, you will always get the value which is less than or equal to minimum of a comma b, right? And we need to find the largest k. It means that we can swap any number of times. Let's say, so this is the actually given array, and I the actual position of this element should be 0, 1, 2, 3, 4, 5. We want this position sign. This is the this array, right? We want this array, but you can see the elements are mismatched. You can see these elements are mismatched, these elements are mismatched, and these elements are mismatched, and these elements are mismatched. What you can do is, the k should be large, right? So you can observe one thing here. When you are doing something like when you are swapping any two elements, right? When you are swapping any two elements, when you are doing AND of those two elements, let's say A and B, when you are doing AND of these two elements, you will definitely get one element. Like the element should be, you are getting some result. The result should be less than or equal to minimum of A comma B. So let's prove this one. Let's say if I'm already told you that here in this case, you can see here the 3 and 1, right? So when you are doing 3 and 1, you got the actual answer as 1, right? That is, when you are doing and of 3 comma 1, that is less than or equal to minimum of 3 comma 1. What is the minimum of 3 comma 1? That is 1, right? We actually got the 1 and of 3 comma 1 is 1, and the minimum is 1. So you can actually see observe that when you are doing and of any two elements, you will definitely get is less than or equal to minimum of a comma b. Like that, the, if you observe this condition, you can definitely say that if I am doing a and b, then I want some k to sort to swap these two elements. I want such k, right, which is large k. So large k is nothing but when you are doing any and of any two elements, there should you should definitely have some element like less than or equal to a comma b. Then the k should be exist k should be exist in the range of 0 to n minus 1, right? So then only we can say that we can able to swap the all the pairs here. And we can see how we can swap these elements. Like let's say if I'm choosing any k here, but the k is not supporting to swap any other two elements. Let's say when I'm having a and b, when I'm having a and b, I want to swap a and b, but when I am doing and of a and b, I'm not getting the and of a and b equal to k. So how can I swap this element? So I am using k as an intermediate node, right? Let's say a and k should be equal to k, and b and k should be equal to k, such that I can use k as an intermediate node here, and I can swap a and b. Let's say I want to swap a and b, but when I am swapping a and b, the and is not equal to k. What I can do is the k which is I am choosing is definitely in the range of 0 to n minus 1, right? So what I am choosing k, and after that I am swapping a and k. After that, you can see again I am swapping k and b. There are three operations you are actually required to swap the a and b with using the k as a medium, right? And the intuition is very simple here. When you are when the elements are not in the correct position, you can simply do the AND of those elements. Like you will get here like 1 1 1 0 means you will get 1 here, again 1 here, 6 and 5 means 1 1 0 6 5 is 1 0 1, again you will get 4 here, 4 here, right? Let's see. So you can see the possible k values here. If I want to swap the 3 and 2 here, you can definitely get that k should be equal to 1. If I want to swap 2 and 3 here, the k should be 1 here, right? If I want to swap 6 and 5, 6 is 110 101. Then the value should be definitely 4 here. But this is also same, right? So this is a possible values of k which I can use to swap these two values. But you can see I can use k is equal to 1 also, k is equal to 4 also. So which value is the best value? In the question we asked that we need to find the maximum value. Let's say the maximum is 4. If you use 4, you cannot swap the 3 and 2 here. Because in 3 and 2 you can see this is a 3 and this is the 2, right? You can see this is the you are getting value as 2 here. Sorry, this is the 2. Okay, you are getting 2, but you cannot swap these elements. You need to find some maximum set bit element. Let's say if I want like 3 is like 1 1, for 2 1 0, for 6 is like for 6 you can see that 1 1 0, for 5 1 0 1, right? You need to find such element which can actually help to swap all the elements using that k. Let's say if you AND of all these elements you will definitely get 0. So you need, if you use k is equal to 2 here, you cannot swap this complete array. If you use k is equal to 4, you cannot swap here. So if you use k is equal to 0 here, you can simply swap all the elements using the k is equal to 0 here. I'm not saying that if you take any two elements, if you do and equal to k, you will get and of those element equal to k, but it's not possible. You need to take k is equal to 0 which is already present. So I already said that the k is the element which is already present in the range. So using that node, let's say a k b. So like you cannot, if you are not swapping the a and b directly, because if you are having some a and k a and b which is not equal to k, which is not satisfying, like if I am taking 2 and if I am taking 4, they both are not satisfying in these conditions to swap all the values here. So for that I am taking this k is equal to 0. So using this element, what I can do, I can swap this element. After that I can swap these elements. Like I'm using k as k is equal to 0, 0th element as a, this element as a intermediate element that I can swap all the elements. Let's see the code once. You can see this is a code for the problem. So I mean, at the initial I am declaring the boolean flag here, because I want to check that the array is already sorted. If it is already sorted, I don't want to return any answer here, because I just want to return 0. Let's say when I am finding anything which is not matching in the correct position, then I'm simply adding doing and with my answer, right? Let's see let's see some test case from the question. I will take this test case from the question. You can see 323210, right? Test case is 3210. The actual position of the actual array look like is 0 1 2 3. So none of the elements are matched. So what I am doing is I am going here. If both are matching, I am not doing AND of those elements. I'm simply maintaining answer here, so which is storing the AND of both elements, right? And the next one is, you can see here, I need to do AND of all these elements, and I need to store the some common k, common value of common value of k, which is which is inside the range, which is inside the range of, in the range of 0 to n minus 1, right? So if I choose such k which is having sharing the set bits in all the elements, so that k will definitely help you to sort the complete array. So this is the intuition of the problem. You can say this is the code for that problem. I'm simply checking here if the element is not in the correct position. I'm simply adding the end of that element with my answer. So that's all about the today's post contest discussion.